Hi there, welcome. This is the CaddyInfo Cadillac Chat. We do these on Thursday nights. I have with me from the CaddyInfo.com forums, Cadillac Jim.
Good evening.
Hey there, and the dog has come into the room, so I'll let him come in until he scratches to get out, and then he'll get my attention for leaving. The Well, before we started the broadcast, Jim was just saying he wishes we could track the Cadillac platforms by platform name instead of by and I guess the reason we can't do that is the CT6 is going to be on the Omega platform. The CTS and the ATS are both on the Alpha platform. So you'd have to say Alpha ATS and Alpha CTS, and then Omega CT6.
They're different wheelbases, though.
Yeah, you're right. So we could say the Alpha 107 and the Alpha. So that would be a better car name for Cadillac altogether.
Right.
This is the Alpha 107. This is the Alpha 117. By George, you have hit on what they need to do to name their cars.
Yeah.
This car's 117-inch wheelbase. This one's 119-inch wheelbase. It's the Alpha 1. It's the Omega 117.
Yeah.
This is the Alpha 109. This is the Alpha 112.6. Well, the 112.6 may be a bit much.
Put it in meters so it's a shorter number.
Yeah, I'd have to go cipher that out. So the 112 is 10 feet's 120. So the 112 is 8 inches shorter than 10 feet. 10 feet is
Well, I got 112 is
almost 3 meters.
2.8448.
Almost 3 meters, just as I said. Go prove.
And the other one's 117, you say?
So you think it's the Alpha almost 3?
No. Oh, 2.8 conflicts with the displacement too much. There are a lot of good 2.8 liter cars out there.
Okay, so Jaguar brought out their sporty SUV. So I'm looking forward to when are we getting the XT5 V Sport, and I hope that they will, and an Escalade V Sport for that matter. But the big news this week was Porsche and Audi brought out all electric cars for 2017, 2018, which they say are going to be direct competitors to the new Tesla sedan and the new Tesla crossover. And the Audi has a range higher than the Tesla crossover, something like 153 miles between charges. The other exciting news was the Porsche says they're going to be able to go to 80% charge of their new car in 15 minutes. So the current Tesla does 80% charge in 30 minutes at the supercharge stations. The new Porsche is going to go 15 minutes. So 2 more generations and we'll be to a 3-minute refueling, which would give you, the same thing as if you stop for gas now, right?
Oh, yeah. I guess 15 minutes is a long time, though, really.
I know, but they're at 15 minutes now. What I'm saying is if they went from 30 minutes to 15 minutes, then if we go to 7 minutes, and then if we go to 3 minutes, then we're there.
Yeah.
So 2 more generations, and they'll be there. But what they're doing is they're upping the voltage. Now, how dangerous is that going to be?
You're assuming that Moore's law applies to cars, and frankly, the voltage is already dangerous. So,
yeah, that's what I think that we're going to find is people are going to kill themselves on this 900-volt charger.
Well, why should they do that? I wouldn't do that.
Now, do you think if there is are you willing to say that if there is a way to electrocute yourself on a 900-volt charger, that no one will find that way? Is that what you're suggesting?
No, I'm not. Nothing is foolproof because fools are so ingenious. But I will say that the European 220-volt doesn't seem to have any more consumer deaths than the American 110-volt.
Oh, well, I think that's a reasonable way to argue that. But I certainly do think that there's some danger in a 900-volt system.
I agree.
And so, and that, after all, is Murphy's Law in its purest form, is if there is a way to do it wrong, someone will find it.
But I think that if it's advertised as that, well then people are likely to be more careful. I have trouble trying to convince people that 12-volt systems are dangerous. I was talking to a mechanic who threw away the red cap on my positive battery terminal, and I said, I want it back. He says, it's gone. He says, get one out of a junkyard. And I says, I can't. It's not the original battery cable, and the replacements aren't going to be in the junkyards. And he says, oh, don't worry about it. It's not enough voltage to hurt anything. I says, yeah, that's what my watch band thinks. But that ended the discussion, but it didn't help because I still didn't get my battery thing back. I just that was El Dorado. As far as I know, it's still that way. But it's not as bad as one place where a battery died while we were on our way into Philly to see a play, and we stopped at a Pep Boys, and they were out of the battery that was supposed to be in it, and they pulled out a top terminal battery and we put side terminal adapters on it, and that of course puts a live terminal like about an inch from the fender brace. And although that's probably not dangerous unless the battery mount breaks, it's certainly dangerous in a collision. It's just unacceptable for a collision hazard. And so I said no, and they said, well, you can take that brace off and throw it away. Oh.
No, thank you. So here's my question, though. Audi's coming out with the crossover with a huge range to compete with Tesla's crossover that they're hoping to come out with next year. That's going to be their lower cost, wide market car.
Mm-hmm.
So does Cadillac need to bring a battery electric version of the XT5 that does 0 to 60 in 4 seconds to compete with these other kids?
I think it'd be a great idea if they started getting up with the program with hybrids and electrics, because according to people have accepted that that's the future because they put it in the rules for Formula One.
Yes. Now the Chevy Spark already has a very high torque electric engine.
Right.
So GM has the basic pieces in place to just put a battery electric powertrain in. Now, Cadillac has kind of said, we don't care that much about a battery electric vehicle. And certainly the ELR sales have not encouraged them to come out with an extended range electric car. But the ELR also does not have a 0 to 60 time in 4 seconds.
It's good, though. What is it, about 6?
Yeah, it's about 6.5 after their last update. They pushed up the torque of the electric plus the engine at the same time, and I think they got it to about 6.5. But that's a whole different, very, very different range than this Tesla sedan that's outrunning Wildcats, right?
Yeah.
And so I think Cadillac's got to get on the bandwagon that way, where they come and say, we're gonna double the torque in the ELR, or we're gonna triple the torque in the ELR, and not just make it a 1 gallon grocery getter. We're gonna make it a premium sports sedan.
Well, when you start doing things like that, power is like E times I, and I can only be so big. For the bigger the current is, the bigger the conductors have to be, and a lot of them have to be wrapped around a magnet somewhere. So keeping the wire size down means the voltage has to go up to get the horsepower into the motor electrically.
Well, and there's a fundamental challenge there because the ELR was built on a front-wheel drive platform.
Mm-hmm.
And so if now you have to respin it as an all-wheel drive or a rear-wheel drive car because you're going to go bring 500 foot-pounds of torque into it.
Well, it does offer the opportunity for a distributed motor. You can have 4 motors at the wheels and then have about 5 on the drive shaft.
And there's Air Mike.
Oh, that's
Air
right.
Mike
There's no transmission there. Yeah.
Welcome.
Hey, Mike. Hi.
Can you hear us okay?
Sounds like you're underwater.
Put your mic down next to your face. Put your mic next to your face.
It's drilled into the headphones.
Oh, really?
Yes, I hear you fine right now.
Yeah, we can't hear you very well. I can hear you a little bit, but it's like your mic's not in the right place. Are you sure it didn't have a screw-in mic?
Say something, Mike. It's no difference. I thought you might have turned it around to get the mic in the front, but it's not. It's all the same.
And you say the mic's built into the headphones? Is it built into your Oh, he disappeared.
He's looking into it.
He's jiggling it.
Yeah, and he pushed the wrong button or something. He'll be back. Yeah.
Now that sounds like the way I operate my equipment.
See, there he is.
You're right.
Hello.
No, I can hear you, Mike, but it's like you're not next to the microphone. So I can hear you speaking, but it's not distinct. Last week we had a little... Sorry?
I wish I was better at reading lips.
So I can hear you, but it's still like you have no gain on the mic. Or if the mic is far away from your mouth. No difference. Now, do you see the green bars when you speak on your setup? Do you get the feedback there at the bottom of the Google Plus screen that tells you that the mic's going when you speak?
I see it on yours. I don't.
Oh, does that sound? I heard you for a second.
Yeah, suddenly you were better.
It comes when you get down to green bars now.
Oh, does it have? Is it one of those things where it doesn't prompt to speak until it detects you speaking?
I don't even know how it works. I just put them on the same as I always have, and they work.
Yeah, I think that's what it is. You have to say first to get the mic to pick up.
It's a repeater issue.
No, well, it's a threshold issue. That if what your mic is doing is it's muting itself except when you speak, and so if you don't speak up, then you stay on mute.
Oh, I guess you guys can probably hear and speak at the same time.
Yes.
Yes.
Mine doesn't. It cuts out. So, like you're talking about.
Well, that would mean that you're getting one way. I think that's a sound card issue. That the earlier sound cards could only do one direction at a time.
I think his earphones are a repeater, like a cell phone.
Send me your address, and I will send you a headset.
Before, though.
I will send you a headset, and a USB headset, and you can just plug it in. And then, because are you plugging yours into your sound card or into your audio port?
I plug them in. They're wireless.
Oh.
They're not plugged in anything, but they can plug into the USB cord.
Okay, so it's a USB headset. So yeah, it's just some kind of microphone setup issue. Anyway, welcome, Mike. We're glad you're here.
Yeah.
Okay.
Air Mike.
Glad to be here, such as I am.
So we were just discussing, because Tesla has a high-performance battery electric crossover, and now Audi has said they're bringing a high-performance battery electric crossover. Whether Cadillac needs to be rushing a high-performance battery electric XT5 out now that they're bringing us the XT5 to replace the SRX, whether they should also have a battery electric variant of it, a 0 to 60 in 4 seconds kind of version.
Sounds like a good vehicle to me.
Yeah.
For 30,000. They need the high performance car with twice the performance of the ELR and half the cost. And then I think they'll be there.
Run it on 12 volts.
Yeah, I don't know what Porsche's system runs on. Before they were telling us we needed to go to 42 volt car systems, because that was going to help with having electric air conditioning and electric power steering, and it would help with the start stop and with other things. I am a big fan of us getting to electric air conditioning and away from engine driven air conditioning, because in my mind somehow I'm going to end up with cooling from my supercharger that way. And I still want a dedicated air conditioning system for my supercharger.
You may only be getting a part-time mic tonight. The Chiefs are playing at the same time as we're on here, and I have to be watching that.
Oh, I see. Okay, so if you seem distracted, it's because the Chiefs are on?
It's because they're doing something, maybe.
Well, we'll hope that they don't have any big plays then, so that we have your attention.
Save it for the second half.
You know, it just occurred to me, you could make up a complete football team out of the Republican candidates, including the bench.
They'd be all donkeys.
And the bench, yeah, there's 16 of them.
Well, the elephants, I guess, they would go as, right?
Well, they'd use them for center. And running back.
So, Mike, did you have any other Cadillac topics you wanted to address tonight?
No. I've been out there trying to find a communications issue with my ABS traction control on my STS, and I'm getting nowhere.
Oh, no.
Your ABS did what on your STS?
The ABS traction control light are on, and it doesn't seem to have communications, and it stemmed from me putting a new motor mount in and dropping the cradle 4 inches so I could get it in.
Oh, look.
I'm having a hard time finding it.
Look at the EBTCM connector. You probably stretched the wiring harness at the connector and maybe pulled a wire out of it.
I've been looking at them. I've cleaned them. I've took them off, and I've put new grounds on. And
it's one of those things. That connector is one of those things that looks good while you're checking it, and it gives trouble when you're driving. Pull on each of the wires one at a time and make sure they're all tight, and one of them been pulled loose or pulled out.
The problem is sitting there doing nothing. The car lights go out. And until I put it in gear and move, it doesn't have a problem.
Yeah. Well, you have a nice day.
I'm not.
No, that's a classic definition of an intermittent fault, right? So
yeah.
You're doing the right things. You're going to have to track it down to one of the connectors needs to get jiggled. But you need it to misbehave while you're jiggling it, right? So you're going to have to flex the connector, and you're going to have to put the voltmeter on it, and then flex the connector, and keep watching the voltmeter.
Right.
Or just replace the whole thing. Just start replacing cables one at a time.
Oh, yeah. That'd be cheap, wouldn't it?
Yeah, there you go.
Enough about my old junkers. Let's get on to the new cars.
So, I think I would like to make the argument that the LF3, the turbocharged 3.6 liter in the V Sports, and the CTS V Sport and the XTS V Sport, and the LF4, which is the high pressure version of the same engine, the Cadillac redesigned some of the internals in the engine between the LF3 and the LF4, but basically the LF3 is a 12 psi turbocharged 3.6 liter. The LF4 is an 18 psi turbocharged 3.6 liter V6. I would like to argue to you guys that those engines are being tremendously successful right now. That with the 420 horsepower in the LF3 and now 464 horsepower in the LF4, and the aftermarket is going nuts with them, that apparently they are detuned from the factory quite heavily in the low and mid RPM, and so all you have to do to get more power out of them in the tuning program is tell it stop holding them back. Stop reducing the torque of the engine at low RPMs. and basically the LF3 is picking up about 70 or 80 horsepower, and I would expect the LF4 is going to do something very similar, and so that turns it suddenly into a 500 horsepower turbo 3.6, and I suspect the LF4s would be pulling 525 or 550 horsepower with very light tuning.
Same tuning, you'd put the 6.2 at over 1,000 horsepower. Where do you
Yeah,
think
if it were
you'd want
making
that?
the same, if it were making the same output.
Anywhere near.
Yes. Now, the criticism of the 3.6 liter has been it's not smooth enough. That's what the magazines have complained. The criticism of the LF3 or the LF4 have been that they're not roarty enough. You know, one of the problems with turbocharged engines is they're somewhat muted because of the turbo, right?
Yeah.
And so the magazines are complaining that these engines don't sound sporty enough.
Well, they could do like Ford and put it in through the audio system.
Yeah, they actually do some of that, I think, but they're not. They're actually sending actual vehicle sounds, though, not simulated sounds like BMW is doing. But I do think they're channeling and well, maybe they're doing the other thing where which transmission mode you pick between sport or track changes the sound of the exhaust on the new ATS-V. In other words, the sportier you have the car set up, the louder the exhaust is as you change the suspension settings. What?
Like a good choice to me.
Yeah, it sounds like a good choice to me. I think that two-channel exhaust, like on the XLR-V and some Corvettes, is an interesting approach. In other words, part of the exhaust is blocked off around town, and then when you get to high RPM, then it opens up a whole nother channel that's basically a straight exhaust.
Well, cutouts have been around since time immemorial.
But I think they avoid them in cars for the complication problem and for the expense, right?
Because they're illegal.
Well, there you go. Or they're actually used in some cars, though, so there must be a way to make them where they are legal.
They just put a muffler in the secondary path so that the sound's still legal. That's what they do.
Yeah, it's not a complete cutout. You're right.
Yeah.
I mean, it's just channeling through a more roarty muffler instead of no muffler at all.
Yeah, I bought a used car one time and fixed the engine and carburetor and found out that it had a rather unconventional cutout. Whenever the secondaries open on the four-barrel, it'd blow the muffler off.
Wow.
And I had to crawl into the car and jam it back on. But I was younger then. What was that, Mike?
You needed a bracket to catch it, then you could cable it back.
Oh, I just got rid of that was just something else I fixed next. I just got in the car and I was straightening it out. And I found all kinds of weird beanbag stuff on that car. It took a year to straighten it out.
Hey, Bruce, you mentioned how much pressure them turbos were putting out. How much is on your FCS, and Jim, how much on your CTS? How much did they boost them?
12.5 pounds, but I've never seen it go that high. 10 pounds usually.
Yeah, it's 12 psi also on the STS-Vs.
Mm-hmm. It can go to 15, but that's only at altitude. In other words, the manifold pressure at maximum boost is constant with altitude.
What happened was Eaton made the supercharger, and so the one on the STS-V was like an MP122, and then the one that go into the CTS-V, the LSA engine was the very next generation of that same family of superchargers. So it was a little bit more efficient, but a 1.7 liter version because it was a little more efficient. And then the Corvettes, the supercharged Corvette of the same generation, got the 1.9 liter version of the same supercharger, meaning each rotation put 1.9 liters of air through the supercharger.
And then they run them at double RPM.
Yeah, and then the new ones, the LF4 actually gets an even smaller supercharger because it's more efficient again. And so the aftermarket will be to take that off and put on a bigger supercharger.
No.
You know, that's what the aftermarket would do with one of the things people were doing with with the LSA and the CTSV was they were switching over to the superchargers from the Corvettes. But then they learned just change out the pulleys and it was much simpler. Some of the people were putting on a Whipple supercharger instead, but I think by and large people have discovered that if you just change the cam, change the pulleys, change the cam, put on the headers, put in an exhaust, then you can make more power than you need.
I make more power than I need stock.
Yeah, if you change the upper and lower pulley. Now they have, of course, they have more liters, but they have the new supercharger has a little more range in it than the one in our cars does, the MP 122, because the one in the STSV or the XLRV is basically at the top of its efficiency range in the car the way it was designed. So if you spin it much faster, that's why when you see people put on new pulleys, then sometimes they say they make more power, sometimes they don't. They just say they make more torque. And what the problem is that because the supercharger is running at the top of its efficiency band, that if you run the supercharger faster, then it actually makes more heat. It makes more air, but it heats it up out of proportion to how much more air it makes.
Frictional losses. Which
reduces the efficiency, and so it reduces how much horsepower you gain. And so you kind of hit a wall there with the MP122 unless you can figure out a way to cool the air. Now, if you combine it with nitrous or you combine it with a meth kit where you're gonna cool the air coming in, then the smaller pulley works great. Or if you only run it up north where it's cool and not in Texas, then a smaller pulley works great. And it still helps all the way through. So what you'll see is because you increase the pressure early on, right, then it'll put your torque up right away. It's just when you get to peak horsepower, you can't. It's hard to make more peak horsepower because you're heating the air up so much, unless you figure out some other solution to cool the air. Now, one of the things that Stegemeyer was doing that one of the XLR guys has done is that snakebite kit, which actually is designed to make the supercharger itself more efficient and have a higher, to put out more air with every revolution, and so to the extent that that works, then it's free ride.
Well, if you're going to have refrigeration, cool the air before the supercharger.
Yes, please. You have to cool the air before the supercharger because you can't. If you cool the air after the supercharger, one of the things that Kenny Bell argued on one of their essays was that there's no point in cooling the air after the supercharger. You can't increase the density of a fixed volume of air.
Well, there is a point because the air is hotter and a higher pressure, and you can't. You have more of a problem with detonation. You have to drop the compression ratio more unless you have an intercooler. And it translates into torque and horsepower.
You can change the timing, you're right, but you won't change how much air you have in the charge if it's a fixed volume of air.
Right. But you can
can't
increase
lower
the
temperature and you can't add more fuel. You're right. You can have an incremental improvement because of the IATs. So if I run 30 degrees cooler and I don't have 2 or 4 degrees of timing pulled because of IATs, then I can make more power in proportion to that missing advance.
Well, I think the intercooler makes a lot more difference than just a few degrees of advance. And I think that it makes a difference in the compression ratio you can run. Like I still run 9.5 compression ratio with my engine, and without an intercooler, you're talking 8.5 or 8.
Oh no, I agree in terms of design. That's absolutely true. I'm just thinking in terms of the cars as we have them in the driveway. Their argument was you can't cause more air to get the engine by cooling the air because fixed relationships.
Yeah, right.
Now, in some ways, that seems like a facetious argument to me because of the things that you're saying. Is the truth of the matter is, if I cool the air going into the engine, everything gets better.
Right.
So if I can figure out a way to cool it, but you run into other design problems, like if you spray it with meth, you can cool the incoming air charge, but the supercharger blades don't really like to be coated with water and meth. It can have an effect on the blades as they're turning at 22,000 RPM, and so if you spray it after the supercharger, then you have to drill into your supercharger instead of drilling into the cheap plastic, which makes it more iffy, right?
Oh, yeah.
Now, if somebody would come out with there's actually a screw-on cap on the supercharger, and if somebody would come out with a screw-on cap that was an easy piece replacement that had nozzles built into it to spray the meth there, then I think that would sell like hotcakes. Mike would buy me one for my birthday, and we would have cool IAT temperatures.
Right, we'd be checking out your blog.
Well, if the manifold still has injector bosses on it, you can inject it down there. You spray it right on the valves.
Well, the injectors are filling up the injector bosses.
No, I thought was LT have direct injection or not?
No, our engines, the LC3, were port injection.
Oh, okay.
The LT engines, I think, are direct injection, but the LSA and the LC3 were port injection.
Right.
But so that's been the trade on meth. I still think a meth kit would be fascinating to play with, and maybe next summer I'll do that with my SDSV, because it's something that a home hobbyist can set up and spray into the intake, and it's basically just a aquarium pump and a sprinkler nozzle and defroster fluid. And so you buy defroster fluid by the gallon at Sam's, and that gives you 50% meth and 50% water, and then you spray that into the intake of the engine at a measured amount, and use that to cool the incoming air. Now, the other, if you don't want to have anything to do with spraying something into your engine, the other giveaway is spray it onto your heat exchanger for your intercooler. In other words, douse that in water and use an evaporative cooling effect to try and lower the temperature of that. But as I say, my experience, even when I was doing the intercooler pump experiments, even when the intercooler was hot with the car running 100-degree heat in the driveway, the water coming out of the intercooler coolant itself was not hot in my hand. And so I think the change in temperature of that water is minuscule compared with the change in temperature of the air going through the intercooler.
Well, I think the air going into the intercooler is probably, up to, say, 150 degrees. You can compute it from Boyle's Law and the boost and the ambient temperature. But
now, one of the things I've been surprised at as I play more with tuning on the LH2, the unsupercharged car, is how high the manifold air temperatures get without a supercharger. Just from the manifold being attached to the engine and the engine's, staying 230 degrees, that very rapidly the air going into the engine will rise to 230 degrees if you're sitting in traffic.
We'll put the polyurethane back on your beauty cover. And,
it's on there.
Well,
my beauty cover is on the car.
Well, a big point is that beauty cover is to keep the underhood heat away from the manifold.
It's not working. I want my money back.
No, you need another beauty cover. Get a.
Oh, you think my beauty cover's defective?
Yeah.
I'm insulted.
So sorry.
Oh, I need a big hood scoop with fresh air pouring in. That's what.
There you go. That works.
So
do you have the side porch on the fender to let the underhood air out?
Not till 2009 on the XLR, and mine it did not have. Now some of the guys say.
What's that, Mike?
They weren't functional anyway, were they?
No, which I object to. I don't think you should have anything on the car that's not functional. Some of the XLR guys hypothesize that if you remove the trim from the front of the hood, that'll allow more air to come in under the hood and cool off the whole process. I
Yes,
am
it
not
will.
certain that that's true.
Oh, it's true. It'll also let pigeons, Coke bottles, and drive shafts through into the intercooler, the evaporator, the radiator, and
But
the steering cooler.
but my theory is that Cadillac has a plan for how they want the air to flow through the front of the car.
Yes.
You know, that air hits here and then it's directed through the radiators and so on. And so I don't want to, it could be that by introducing air under the hood over the top of the engine, I'm actually defeating my purpose, if you see what I mean. That what they have is air coming under the car and up through the engine and in through the nose and up through the engine.
That's
And
true.
so
The hole under the bumper and the grill is your one.
Yeah. Now what I did do with my STSV is I rerouted the brake duct to where it channels air directly into the air filter, so that it's not a ram air effect because it's not sealed, but it does channel air. You know, I redirected and put a tube set up. I was not able to measure any difference at all from doing that. But I did do that in order to determine whether there was an advantage or not. Because you also hear people say that's the way to go, but
yeah.
I didn't measure any difference in incoming air temperature, and I didn't measure any difference in performance. Now I do, when I went to the Volant intake on the XLR, I do frequently detect no difference between the incoming air temperature and the ambient air. In other words, once I can get the XLR rolling down the highway, the incoming air as measured at the MAF goes to exactly the same temperature as the ambient air. And so it's not getting any preheating from the Volant intake at all, whereas I did see a normal 5 or 6 degrees of preheating from the OEM intake.
Wow.
Just by the time the air would, because the air had to make 2 90-degree turns through the plastic, and here in Texas, everything under the hood is hot by the time you go to do something. So, although the weather's changing, which is driving me nuts in my testing, because
wrap your intake. If you were getting 5 degrees of heating before, you probably still are. Wrap it and get that 5 degrees back.
Yes, and I've seen people doing that where they take basically header wrap or insulation and wrap it around their intake in order to further isolate the cool air. But as I say, if I can get away from traffic, part of the thing is there's stoplights on the way to the test area. But if I can get away from traffic, then the car's running no preheat. You know, the air is going straight through, and so I'm happy with the setup. But I agree, if I could figure out a way to further isolate it. The other thing that the BMW guys have done sometimes is they'll put little spoilers or wings in the intake to further deflect air into their cone filter. In other words, they'll put more air direction in the nose inlets to try and push air to the intake. And I haven't played with that or tested that. I think what's driving me nuts right now is because the weather is changing and we're actually getting some humidity because we've had some rain lately. So before I was testing, and day to day I would have very, very consistent results. And if I made a change, I would see the change. But now I'm having the weather change, and the tool I'm using doesn't compensate for humidity. And humidity can have a very large change on how much power the engine puts out. And so I'm trying to go through and force it to correct for humidity. So that's my hope, is that I can get back to very consistent day-to-day readings, baseline readings, so that I can continue tuning the car. Because the other choice is just going to be I'll have to run baselines each day. In other words, you take tune, the baseline tune, you run the test, you stop on the course, change to the tune you want to test, then you run it. and then you compare. You know, you only compare the tune. You can only compare runs made on exactly the same day. You can't compare it to yesterday's run.
How difficult a job is that, changing from one tune to the other?
It's not difficult, but it's risky. And by that I mean when you're writing a new calibration to the car, there's sometimes some small percentage of a chance that it won't go well, or the laptop will crash in the middle of the write, or the car will glitch in the middle of the write or something, and the car will become an object of art instead of a car. And then or
like a big shiny brick.
Like a big shiny brick.
Yeah.
Or what I found on a couple of times, the car will tilt, will decide that it can't communicate on the bus with any of the computers, and then and because it recognizes that it's not communicating well, it stops listening to the bus, and then you can't communicate to tell it that everything's okay with the scanner. And so my constant thing is, if I'm going to strand myself, I would prefer to strand myself at home, where I have more gadgets and cars and so on to deal with it. And so if I vastly prefer to do calibrations only in my driveway, and only using certain rituals and superstitious processes in case something goes wrong. You know, worst case, I can just push it back in the garage and come back and deal with it another day.
Yeah.
So using a previously used tune is no different than a new tune as far as changing it out there in the wilderness. It's liable to have a glitch just as much as a new one.
Yeah, you know, it's just the process of, it takes about 40 seconds to write the tune to the car, and then it delays 10 seconds to make sure the transmission computer is listening, and then it writes the transmission computer tune, and then it's done. So it's very quick. Now, along those lines, HP Tuners has come out with something called an N-Gauge. And what the N-Gauge does is it's a round digital gauge that has a couple of settings on it, and it has a memory card in it, and you plug it into your diagnostic port, and the gauge acts as a gauge. So that's how you and I could have IAT2 gauges in our supercharged cars, right? So that are the same thing with Jim.
Yeah. I love it.
And that would be, so that's easy to set up. You just plug it into the USB, you attach it to your center console there, and you have an IAT2 gauge. Now, but the really interesting thing about that is it's also set up to change tunes on the fly. So in other words, you tell it, okay, I want to use tune 1, and it will reprogram, it will recalibrate the car to tune 1. And then if you tell the gauge, I want to use tune 2, it'll recalibrate it to tune 2.
When you say fly, do you mean actually driving down the road, or you got to pull over to do this?
Yeah, you're going to want to pull over, and you turn the car off and put it in accessory only.
Right.
Because you don't want the car running when you retune it. Ask me how I know. When you change the computer to be blank for a moment, you don't want the car running.
Because it says, whoa.
Yeah, right? It will stop. It will stop.
Yeah.
I had actually done that, and you know, the self-diagnostic mode that you can do on the Cadillacs. Sometimes when we were on long road trips, I would put it into self-diagnostic mode and play with this with this view or that view, you know, while you're driving down the road. And in retrospect, that wasn't a wise thing to do, because the same way that while you're in diagnostic mode, you could hit the wrong button and tell the fuel injectors to turn off, right? Or tell it to do the wrong thing anyway. But so this N-Gauge would be interesting, because you still have the same risk that you're reprogramming the calibration of the car, but it's set up to do exactly what I'm describing, which is, run one calibration and then switch to the other calibration. So what they have in mind, though, I think is, let's say you had a normal driving calibration and a race calibration, then you could always keep your race calibration right there in the car with you, right? And so you could have it permanently installed and just hit a button and switch over to your race calibration, and then off you go.
So when you're getting ready to have a race, you'd say, just give me a minute, I'll be ready.
Yes, just like in American Graffiti when he went home and put on the other wheels and took the center out of the exhaust and got the car ready to race, right?
Right.
Back in the day when I was going to run my Corvette in the Jim Conner hill climb, all I do is put the steel wheels with the big rims and the big street Michelins and change the plugs and the air cleaner element, and I was done.
Yeah, I always have very mixed feelings on this topic because I want the car to do as well as it can, and I totally get that it has better performance when it's cool, and it has better performance, when nothing's in the car, and da-da-da. But I'm also, where I get conflicted is, I'm not driving the car when I'm driving the car every day, it's in traffic, right? It's at temperature, and so don't I want to test the same way I'm going to use the car because that's what it's actually making?
No.
I don't want to test in such a way to just get a maximum score on the test. I want to test in the way it's actually going to be when I'm driving it.
Well, what are you going to do about traumatizing all those people driving their Toyota Camrys to work?
Well, I don't mean test during the drive to work.
Oh, well, then you got to do it.
I mean, the test should be at the same conditions as you normally use the car. That's what I'm trying to say. But yeah, for comparisons, you like to compare back to an ideal state. And, Cadillac rated the engine in kind of an ideal operating state. Part of the reason that they ended up with 469 horsepower was they were being too harsh on the intercooler coolant temperature of the water. Interesting story, right? That they said when they first started testing the engine, they said the water temperature for the intercooler coolant should be worst case. But then as they studied the spec, they decided no, it just needed to be, in a reasonable range. And when you modulate the temperature of the water of the intercooler coolant, then you can make more power in the engine. And so we know that lowering the water temperature of the intercooler coolant will make the more power. We just have to figure out how do you do that on a consistent basis in 100-degree heat.
Well, I would say put slushies in the reservoir.
And this is what real people do,
is
they make the reservoir with a big top on it, and when they want to run their test, they fill it up with ice, and they close the big top, and then you let that run through a little bit until the ice melts, and then you run your test before it heats up again.
Right.
But again, that doesn't tell me anything about how's my car going to do when Mike pulls up next to me in his hot rod XLR.
And you've been driving for 30 minutes.
And I've been driving for 30 minutes. Or out on the highway when I ran into, a Shelby Mustang or a Roush Mustang version 3, whatever the hell that is, an 800 horsepower Mustang. I didn't have time to stop and cool my intercooler coolant down to the appropriate range.
Well, lead him through a freeway interchange loop and just laugh as he struggles to hang on. Drive away from him. That'll work.
Yeah, but
so
I also
you need the air conditioner version.
Yeah, well,
I need the air conditioner version that I haven't got. So, and actually, I think there may be a poor boys version of that, where you just take. In other words, what the cool gadget the guy's doing is it routes the air conditioner refrigerant through a heat exchanger, and then routes the coolant through the outside of the intercooler coolant through the outside of the heat exchanger, so that it's a water-to-water heat exchanger. But we have some 40-degree air conditioner refrigerant lines going through our engine compartment, and so if you if you could strip the insulation back off those and then put them in the middle of a tank that was running intercooler coolant through the outside of the tank, then you'd have the same effect.
I think the Freon right out of the evaporator, the restriction, is more like 30 degrees. It comes out the air conditioner vent at 40.
Now that's
the air.
That's the other thing I need is I need a Freon bottle that I can spray at my intercooler coolant tank that would instantly chill it to 50 degrees.
Well, you can.
And then I'll just hit that button. This will be like the Fast and the.
Just put that right in the front radiator if you're going to be doing that.
Exactly. Just spray it right on the and they make
the air intake, because if it gets in to the supercharger air, then it turns your whole motor into a phosgene generator.
Well, yeah, it will replace the oxygen, and that's the danger of. They actually make CO2 kits that you can spray at your heat exchanger for the intercooler.
There you go.
The problem is if you get the CO2 into the intake of the engine, then it ruins your oxygen, ruins your mixture, right? Mm-hmm. So you've got to figure out some way to spray it at the nose of the car without getting it in the intake. So but the what people do though is there are intercooler coolants that use water. You just use the water from your headlight system,
yeah,
and spray that at the intercooler heat exchanger. I actually tried that anecdotally. I monitored my intake air temperature with the car sitting in the driveway and sprayed water at the heat exchanger to see what difference that made, and was not able to detect any difference. But I did not have, and I ran a fan across the heat exchanger, but I did not have the car running at highway speeds to see what difference it made then. And I did not note what the dew point was for water to evaporate that day in Texas. You'd want the dew point to be pretty high, right? Because the dew point is the point at which water will evaporate, the temperature at which water will evaporate. And so if you ran it on the wrong day, anyway, the whole point to evaporative cooling is to get the water to evaporate. So if the water doesn't evaporate,
the dew point low,
there's no cooling.
That's the point at which water condenses.
Yes. You're right. I'm getting it wrong. You're correct that I'm getting it wrong. And so a low dew point, a low humidity day, then you spray the water on you because you want the water to evaporate in the heat and cool the heat exchanger as it evaporates. But again, I'd have to figure out. So, yeah, that would be a good thing for us to test next. And there are kits that you can buy that are already set up to do that, which makes it some easier. It basically has a big hoop. Now, Mike, you have an aftermarket heat exchanger on the front of your XLRV.
No.
No?
No, I just have cold air intake deal.
Okay. So I have an aftermarket heat exchanger, the Timmy C version, but it doesn't have fans on it. So that's the other thing that some of the Ford intercooler guys do is they'll put twin engine, radiator fans on the heat exchanger for the intercooler and just run, 12-volt fans on it, because then you can run the fans at full speed while the car's stopped and keep air flowing across your intercooler, across the intercooler heat exchanger. Yeah. But again, I'd have to measure it to see what difference does that make.
I need to ring off because I got to get up at 5 a.m.
Thank you for being on. I'm sorry we've already run an hour, and yeah, you're right that we should probably wrap up. But thanks for being on, Jim.
Oh, y'all can stay. I just have my problems.
It's good to see you. Have fun at work.
Okay, keep that intercooler cool.
So I think my next experiment is going to be to figure out on the LC3 is going to be able to figure out a way to measure the water temperature of the coolant, of the intercooler coolant directly, because my theory is that it actually goes through a very narrow band. That it only goes from 80 degrees to 90 degrees or something like that.
Right.
And so that, to me, that means it's going to be difficult to change that a bunch.
Keep it at the 80 all the time.
Yeah. The other challenge is it's not a problem with the water heating up because of your acceleration, that in a quarter mile, you don't get one complete circuit of coolant.
Right. So whatever you have when you start, you basically have when you finish in that short distance.
Yeah. It's whatever temperature the entire circuit is what temperature you're exposing the incoming air to. Now, if you keep going past the quarter mile, basically when I did the math on this, what I discovered is that it takes something like 8 seconds for one drop of water to go all the way through the intercooler system. And so you'd have to accelerate for more than 8 seconds before you're heating up the water, if you see what I mean, before
Right.
you're subjecting water 2 times through the circuit. And so, but I think in order to understand better exactly what's going on there, we'd have to measure the water temperature. Now, I happen to have, because my tank, I have a 1 gallon aluminum tank in the nose of my SCSV, which has a plug on it that's ideal for putting in a temperature sensor. Then I'd have to run a wire from there back to the dash where I could read the output. But if I did that, then I could monitor the water temperature, and then that would tell us the relationship between the water temperature and the air temperature without doing, with no other changes. And it would let us tell things like, if you added fans to the intercooler, does that help? Because if we could actually measure the water temperature directly, then we could see the impact, right?
Right. That's why I like reading all that stuff you do.
Well, stuff
I'm never going to do.
Some of it is just, proving out what you'd expect. And that's what I found with the pump, right, is that you're not really changing the speed of the flow of the water through the system. You're improving it, but you're not improving it very much. And the factory selection was actually pretty excellent for the pump. Thank you for being on tonight, Mike. It was good to see you. We didn't get to my other topic, which is I wanted Jim to go through with me all my temperature correction calculations. But we'll get on that topic another night. But I think it's important in my test that I correct for humidity. And that's what I'm going to start doing now, is watching my barometer and correcting for humidity. And then see if that helps with getting consistent test results. So I'm going to keep exactly the same tune in the car. I'm going to go out and rerun the same test, and then see how the corrected results compare with the corrected results from night before last, given the new method of correcting for conditions. Because what I want to get back to is where corrected for conditions, then we see the same results over and over again.
Right.
Now, within a range, I'm seeing the same results. And the problem is, the car's putting 230, 240 wheel horsepower, and I'm wanting to tell a 5 horsepower change. And of course, even on a chassis dyno, you might see 5 horsepower difference in 3 runs, right? Run to run to run. You're going to see some difference just because the computer, had something else in mind that time. And the same thing, I would see run-to-run differences when I was focused on 0 to 60 times, because the computer had something else in mind when it got this molecule of air on the next run. And so that's the. But I need to figure out a way. I need to figure out what I'm missing. I feel like I'm missing some variable in the test that I'm not correcting for something. And I got to track down what's the something. Because when you see a 10 horsepower change from one test to the next in a range where you made no changes, then you're not correcting for something.
Right.
A 5% change is too large for it to just to be you know. So yeah, it's a
So-
day-to-day problem, but there's some change from one day to the next.
You had wrote one time something about HP tuners had reported X amount of horsepower. I don't know what it was, and yours wasn't matching that. And I suppose a person could buy their tune and then try to duplicate it. Is that possible?
So I think you're missing. I think you're mixing two different stories. HP Tuners is the software that I use in order to tune the XLR, but
Right.
Mad Tuners offers a tune
yeah.
for the STSV, in which they were able to find some increased performance from the STSV. So yes, you could buy their tune and then look to see what they did and incorporate that in, but I wouldn't feel comfortable publishing what it is they did.
Right.
Because they're making money doing it, right? Almost the reverse. That if I found the perfect tune, I'd probably feel perfectly comfortable sharing it with them so that they could sell it to other people, right?
Right.
But,
and give you a little commission.
But yeah, here's, I'll send you referrals. But yeah, they're making money selling whatever it is. So they did a lot of dyno testing and came up with some combination that caused an improvement, and they're busy selling that. So we wouldn't want to disclose their proprietary information, but it does suggest that there is something there. And I think I found one of the things, right? Because I got an instant on the same day. I got a 12 horsepower improvement by changing the VVT timing of when changing the retard on the intake. And so I'm excited about that. What I'm upset about right now is then when I did some really fine tuning on the same program, then I got a big difference. And so I've got because the weather here is changing because it's September. And so in the first 3 weeks of September, it gets cooler here, normal weather pattern. And so my day-to-day readings aren't lockstep, but I think it's because the humidity. And so that's what I'm trying to isolate is if I can find the right weather correction, then I can go back to my day-to-day readings being lockstep, even if the weather changes. That's my theory, but it makes for fun testing anyway. So, again, don't miss the fact that I'm having the big fun. But I do feel, but the software I'm using doesn't correct. It only corrects for barometer, which is pressure and altitude, and temperature. It doesn't correct for humidity or dew point. And so that's what I'm trying to correct for now. And I did that back when I was testing the STSV. Is I would correct. I would use the Shellquist programs to correct for humidity to dry air, and then take the dry air number and put it into Virtual Dyno so that Virtual Dyno was corrected to dry air. But I felt bad because I was taking a correction from one program and putting it in as the correction to the other program. And that seemed like bad science to me. But because Virtual Dyno doesn't correct for dry air, and because I've been able to tie out that with doing that, I get a better correction, then I'm going to decide it's okay.
It's going to be the best choice, isn't it?
Yeah, exactly. So, but yeah, what I need you to do is come down for the weekend and let's test the two cars side by side, and then that'll give me better information.
Okay, maybe around the first year, I'm thinking of going to Phoenix to see my daughter. Maybe I'll drive down there.
Oh, perfect. You come by and because that way we could run one program on the XLRV and a different program on the STSV for the timing, and then see what the output was side by side. Now, the other thing that the engine constantly estimates what the torque output of the engine is, and it uses that information in order to make decisions, right? in terms of how it runs the torque management and so on. And so one of the other things that I keep up with is, and of course, if it'll tell you torque, you can calculate horsepower because horsepower is related to torque and RPM. And so one of the other things I keep observing is the engine's analysis of how much power it's making isn't matching up with the virtual dyno output of the power at the wheels. And so I'm not sure why that is, because the engine's really pretty good at estimating power because it's looking at, you know, all the tests that GM did and what turned out better in the test. And so when I don't see the same trend in virtual dyno as I see in the engine performance, it may mean that Cadillac lied about the coefficient of drag, for example.
Right.
And the reason I'm seeing this flat top at 6,000 RPM is because it's getting more drag through the air than Cadillac said it was, and I'm not correcting for drag enough. So if it was 0.32 instead of 0.31 or something similar, then that's what's causing the flat top. Because if you don't take the aero effect out of the equation, then it's going to show. Now let's talk about that. So if Cadillac said that it had better aerodynamics than it actually did, then the program would say it was making more horsepower. I think. Let me go change that in the program. And
yours would be recording lower because of the drag, right?
well, I think so, but
It could be making more horsepower, but it wouldn't be showing up because it'd be getting pushed again.
my first intuition was if Cadillac's wrong, or if they did the CD without the side mirrors or something silly like that,
Right.
then the
You have to put this CD in your program somehow.
yeah, I have to put the CD in the program. So I'm going to save it as a different, so I'm going to say CD 33, save as custom. So we'll save that profile as a CD 33. Oh, I have to name it something like Cadillac XLR CD 33. So Cadillac said the CD was 31. So what I'm doing right now is I'm saving the CD as 33. So and then I'm going to go rename the file because it won't let me load the same file side by side. So I'm going to go rename the 6F file as something else so that I can run the same file side by side without the program knowing that that's what I did. I'll name it copy. I'll name it something snazzy like copy. Okay.
Yeah.
And then I've got the 6F loaded, and now I'm going to load run, and then now it's pointed at the wrong place. So if I go and load run and go to the right place, and 6F copy. And then I've got to put in the right figures. And so we're going to put it to the right conditions, 28.51. Well, first we're going to change it to that car. So I'm going to change it to the custom car called XLR CD 33. Okay, and now we're going to tell it it's in second gear. And now we're going to tell it the weight is the same as our previous weight. And now we're going to tell it the barometer is the same as the temperature is the same as our previous temperature, and the barometer is the same as our previous barometer. So if the CD were really worse than the CD that, so now I'm going to go share screen, which I should have done already. I apologize. So now I'm going to go share screen. So so what I've done here is the blue line, the red line is the CD 0.31, And the blue line is the CD 0.33. And so they all have the same settings, and the only difference between them is the CD is changed by 2 points. The Cadillac said the CD was 0.31, and if they're right, then this line is correct. If Cadillac's wrong on the CD, then we'd still see a flat line out here. We still see the same shape, don't we?
Right.
And so it wouldn't change that. So my supposition was that as it got out here, we'd see a change in this shape. But because this is 40 miles an hour to 60, 70 miles an hour, it really doesn't affect the shape that much, the different CD. It does change the horsepower by 12, which is surprising, going from 0.31 to 0.33.
So it takes 12 more horsepower to push that much more drag.
Yes. Which means that the drag is a very important number. It's not an important number in the side-by-side comparisons, as long as I keep it the same and the car is the same and life is good, right? But it's a very important number for matching up with the dyno. But Cadillac claimed that the drag on the XLR was 0.31. Now we don't know if that means 0.315 or 0.3145 or 0.295.
Right.
But two 100ths in the drag change the output 10 horsepower.
Are you doing rears top up, top down?
Top up. Every run's top up. We believe that the top down changes the CD. I modeled the top down as changing the CD by 0.05. So it actually takes 25 more horsepower to push the car with the top up, with the top down than the top up. But
Really?
That's something else I'd like to test, and that would be easy to do, right? Is run a test with the top up, put the top down, rerun the test, put the top up, rerun the test again, and then look at the three tests side by side.
Right.
You ran what?
I ran that test sort of. I did the drag race that way.
How did you?
Top up and with the top down, and then I put it up, and it took the guy about 5 miles an hour more to pass me.
With the top up?
So with the top up, yes, it took him longer to get around me.
Yes. Now, my theory is that the top down would actually be, so if 0.02 CD made a difference of 10 horsepower, my theory is that the worst dynamics. Now let's talk about this for a moment. What we're doing here is we're saying the performance of the car, if the performance of the car was the same, how would the performance be judged if we change the CD? That's not what we would be doing with the top down. We're saying with the top down, the CD would go up and the performance of the car would have been worse. And so, but I guess you could still model it the same way, right? So the peak was 12 horsepower worse at 2 100ths difference in CD. And so if my theory is right that there's 5 100ths difference in CD with the top up or the top down, which is what they measured with a Mazda Miata with the top up or top down, then you'd actually see something like 25 horsepower difference. If you kept the CD the same in the program. If you change the CD, then you wouldn't see any difference. But what that would let me do is actually tell you what we would do is change the CD in the program until the lines laid over each other. And then that would tell us what the effective CD of the XLR with the top down was. Does that make sense? So that's what I had in mind, is to use the measures to measure the CD of the car, to estimate the CD of the car with the top down. Because there are lots of nights where I'd rather have the top down while I was running my test, except, it lets people see in that you've got a laptop running right there in the seat next to you. But it's more fun to drive around with the top down. So, and my very first test I ran with the top down because I was only interested in the engine outputs that I was getting from HP tuners, and I wasn't worried about running the virtual dyno. But I think the virtual dyno gives more real world, closer to a chassis dyno than the engine outputs do. When you read the tuning boards, they say there's too many things in the tune that can change the calculated torque without actually showing up on the dyno. And so they don't always trust the calculated torque.
Really? I didn't know about that.
Because it's a calculation. And so that's why I run the virtual dyno instead of just tuning to the engine. Because if I could just tune the output of the engine as shown in the tuner, that would be much simpler and more scientific. That would be easier because you can tell right away, hey, that run was better. Look, it was 325 instead of 350. Run it again.
But who knows what made it that way?
And the changes make good sense. That when you increase the timing, the power goes up. When you bring on when the air is cooler, the power goes up. It's not this stuff I see in the virtual dyno, but that's the reason I run the virtual dyno, is because I think it ties more closely with what you would see on a chassis dyno. Now, if I had the other thing I'm missing is a wideband O2 sensor, as I really should have, but we talked about that the trick is finding a place in between the close cat. It's got to be 18 inches behind the manifold and 18 inches in front of the cat. There's not enough room there. So what people do is they stick it in there anyway and just hope it doesn't melt.
Yeah.
Yeah. So now, or they take out the front O2 sensor, tell the computer not just ignore that it's out for right now, and then measure to see, run that, see, calibrate the MAF so that they get the commanded air fuel ratio they need, take out the wideband, put back in the narrowband, and then tune from there. Because as long as you know you're getting the air fuel ratio that you command, then you don't need the wideband in there. You just need it in there to calibrate the MAF, the manifold airflow. Mike, it was good to see you. Thank you for being on. Vinny, if you're watching out there, we missed you this week, and several other people. So don't, lots of other people. So I can't, KHE used to be on with us sometimes. Kevin, we miss you. I wish you would come on again. Thank you, Mike, for being on tonight. Any last words to share with our audience?
No words.
Google Plus designers, if you're watching, I'd actually like the little windows that show the different people that are on the call to be up at the top of the screen, because that's where my camera is. And so that way, when I'm seeing Mike in the window, I'd be looking up here to the top of the screen, and it would look like I was looking into the camera instead of down there where his picture's showing. So Google Plus designers, please move the mini camera view up to the top of the screen where the cameras are.
Put your picture and my picture to a different spot.
Yeah, exactly. And it's probably set up where I could drag that or tell it to do different or something, and I just don't know how to do it. But thank you for being on, Mike. Stand by, and I will stop broadcasting. If you want to be live with us another Thursday night, we do these on Thursday nights. If you want to be live with us another Thursday night, contact me on Google Plus, contact me on the forums, contact me on Twitter or on LinkedIn, and let me know that that's what you want to do, and I will help you figure out how you can be on and be cool like Air Mike and join us on the show. Stand by, Mike. I'm going to hit stop broadcast.